Hi, in this lesson, we're going to explore the difference between inductive and deductive reasoning, and then we'll look at a few examples of both of those. Inductive reasoning is when there's a pattern, and based on that pattern, you draw a conclusion. So when basically repeated events occur, and you draw a conclusion, then you've used inductive reasoning. And then a deductive reasoning is based more on generalizing, or if you draw a conclusion based on general facts, then you've used deductive reasoning. You might also draw a conclusion based on specific examples for deductive reasoning. A conjecture is an educated guess based on a pattern. So if you look at the key word there, based on a pattern, then which type of reasoning would lead to a conjecture? Pattern associates with repeated events, which is inductive reasoning. How do you prove a conjecture wrong? So let's say somebody has noticed a pattern, they've come up with a conclusion, which we call a conjecture because it's based on the pattern, and you want to prove that person wrong, or you have a way to show that their conclusion is incorrect. This is called a counter example. Counter, just kind of like a counter offer, an opposite offer, counter example. And to have a counter example, you just need one. You need one example to prove a conjecture wrong. So if I were to look at a pattern of odd numbers, 1, 3, 5, 7, based on that pattern, I could say all odd numbers are prime, which means they don't divide by anything except for themselves and 1. And that's my conclusion. That's my conjecture. All odd numbers are prime. You could say, I have a counterexample. 9 is odd, but it's not prime because it's divisible by 3. Then that would prove my conjecture wrong. And we could come up with another conclusion after that. It's just kind of like a process of elimination. The parts that make up a logical argument are called a premise and a conclusion. So we have a couple statements down here that we're going to practice identifying both the premise and conclusion. A premise is kind of like these facts that we're gathering, and then the conclusion is our result, basically. So you can have multiple premises, and in some of these we might, and then we're also going to identify whether it's inductive or deductive reasoning. So I'm going to do this first one, and then I want you to practice the next two. Our house is made of brick. Both of my neighbors' houses are made of brick. Therefore, all houses in our neighborhood are made of brick. So in this one, there are two premises that lead to the conclusion. And there's something that sticks out as far as identifying itself as the conclusion. We have this therefore. That's kind of signifying this is what we've gathered. This is our conclusion or our conjecture. So we have two premises here. This is one sentence. I'm just going to label these as far as note taking. This is the second sentence, and this is the third. I can say that 1 and 2 are premises, and then statement 3 was the conclusion. And now we need to decide if this is inductive or deductive reasoning. Was our conclusion based on a pattern, or was it based on general facts? If you can picture the houses in your mind, if your house is brick and the next two houses are brick, or three houses, whatever, are brick, then there's a pattern of brick houses. And that pattern means that is going to be inductive reasoning. So pause the video, try the next two examples, and then come back and check your work. In mine, again, I've labeled the statement so that note-taking is a little bit easier instead of rewriting all the statements over again. It makes it a little bit faster. In number 2, it says the fact that all keyboards have the symbol, and it's a little dollar sign. It looks like an S, but it's a dollar sign. And then I have a keyboard. And then the last statement is my keyboard has the symbol dollar sign. So it's saying these two separate facts, general facts, all keyboards have a dollar sign symbol. That's a statement. I have a keyboard. That's a statement. And then the conclusion is, if I've got a keyboard, then I've got to have the dollar sign symbol on my keyboard. So the premises are going to be 1 and 2. And then the third statement is going to be that conclusion. And since the conclusion is just based on general facts, this is going to be deductive reasoning. And then the third example here, we have basically two general facts. Today is Wednesday. That's going to be the premise. Tomorrow is Thursday, or will be Thursday. That's the conclusion. And there's not really a pattern necessarily here, so this is going to be deductive reasoning. So that's kind of a couple examples of inductive versus deductive. And then now we're going to do a couple examples where we use inductive reasoning to draw conclusions. In these examples, it says use inductive reasoning to determine the probable next number in the lists below. So we've got these lists of numbers and we're trying to figure out what the pattern is. And if we can figure out the pattern, then we can draw a conclusion about that last number. So that, or not last, but next number. So these are all examples of inductive reasoning. And we use a lot of, well, we use both types of reasoning in mathematics, but a lot of mathematics is inductive reasoning, looking for those patterns and then trying to repeat them to draw conclusions. So we want to get in the habit of doing that. First example, we've got 6, 10, 14, 18, 22. Now, we'll talk about this more in depth later, but this is an example of an arithmetic sequence. So arithmetic means that we're adding a specific number each time. And this is pretty simple addition. So hopefully you can see pretty quickly which number we're adding. We are adding 4 in each step. So based on that pattern, we have enough information that we could confidently say that our next number is going to be 26. So use that to help you do these last two examples. Pause the video, try them, and come back. This next one is really fun. It is not an arithmetic sequence because we are not adding the same amount every time. It's a Fibonacci sequence, which we'll talk about later. But this one was kind of fun, and you might have had a hard time finding the pattern because it's a little bit unique. But I hope that you found it because you're going to have a lot of gratification out of that. Basically, what's happening is we're adding two terms to get the next term. So 1 plus 1, let me pull this out so you can see what I'm talking about. 1 plus 1 is 2. 1 plus 2 is 3. 2 plus 3 is 5. 3 plus 5 is 8. 5 plus 8 is 13. Isn't that cool? So you're just adding the two sequences before to get the next one, which means for our next number in the sequence, we are adding 13 and 21 to get 34 as our next number. And then the last example here is, again, it is not arithmetic because we're not adding. You might have tried to adding 6, adding, and it's different every time, so that disqualifies it as arithmetic. This is a geometric sequence, which again, we'll talk about later. And that means that we are multiplying by a specific number each time. Another way you could look at this is 3 to the first, 3 squared, 3 to the third, 3 to the fourth. That's a different way to look at the pattern. That works too if you did that. The way I saw it initially was times 3 times 3 times 3 times 3. So either way is correct as long as you ended up with 243 as your next number in the sequence, then you got it right. That's all I have for this lesson. I hope you enjoyed it. If you have any questions, please let me know. I'd be happy to help. See you in the next one.